So hello everyone, my name is Saurav Singh. I am a student of a lovely professional university. So today we are going to discuss about Q in DSA and going to do a practical life example on Q and do the code on the same. So let's start with basically what is a Q. Q is a data structure used for storing and managing data in specific order. Okay. So it uses a FIFO property, which basically a first in first out property, and it is used commonly used in various algorithm and application for their simplicity, efficiency, and managing data flow. So as you can see that it is written here that a queue is a data structure in fundamental concept in computer science used for storing data in specific order. It follows the principle of first in, first out, where the first element added to the queue and first first one to be removed. Queues are commonly used in various algorithm applications for their simplicity and efficiency in managing data flow. Now coming on the second slide, which basically talks about the FIFO principle in queue. What is a FIFO? It is a first in, first out. Okay, we can see that. So coming, so first of basis. We can say that first, if we can say that when anything comes first in a queue is the first one to going who is going to leave the queue. So, so talking about more about it. So first one is first entry when removed from a queue, we call it head or we can say a head. Okay, similarly, last entry in queue is the tail, or we can say that it is a rear. So you can see that it is here written that position of the entry in queue ready to be served. That is the first entry that will be removed from the queue is called is called the front of the queue, or sometimes we call a head of the queue. Similarly, the position of the last entry in the queue, that is the one of the most recently added, is called a rear, or we can say that it is a tail of the queue. So coming on the third slide, characteristics of the queue. A queue can handle multiple data. As you can see that in this figure, there are multiple data in the queue which are aligned in a proper manner. Okay, so we can say that queue can handle multiple data, and we can, and the second property is we can access from the both ends. We can see that we can access the data from the rear and also from a front also. Okay, so that's why it is accessible from the both ends. Now coming on the third characteristic, that they are the fast and flexible. You can see that these are the basic three characteristics of the queue. Now let's take a the real life example of a queue, so we get a better understanding of what basically queue is. As we see, as you know that whenever we go to take a movie ticket, we stand in a proper queue. As you go first, you take a ticket first, and then you are the first one who is going to leave the queue. So similarly, the one person who is going to enter in the last is one of the person who is going to leave in the last. As you can see that the in this picture, the first person is entering in the queue and taking the ticket first and leaving the first, and the person standing the last is the person who is entering the last of the queue and leaving in the last. As we can see that it is written also here that ticket queue outside the cinema hall is a real world example of a queue where the person who enters the first gets the ticket the first, and the person who enters the last get the ticket last. As you mm, After taking this example, you can betterly understand what basically queue is. So now let's talk about two main operations in a queue. The first one is NQ and the second one is a DQ. NQ basically is adding an item to a queue, and DQ is deleting an item from a queue. In further discuss the two main operations of a queue. One is NQ and the second one is DQ. Now coming on the NQ, what basically NQ is? When a new element is added to a queue using an NQ operation, it is after the last element of the queue. Means NQ is a basic operation in data structure which used to insert element from a rear side. Okay, or we can refer it as a push or insert. Okay, after inserting the element, the rear pointer element shift one step forward to the new element, which means you can see that here in this diagram, when a element is added from a rear side, the rear pointer element shift one step forward and a new element is added. This is what is written here. NQ is a basic operation performed in a queue. Data structure to insert an element at the rear end of the queue. We also refer it as a push or a insert. Okay. Here it is written that new element is added to the queue using NQ operation. It is added after the last element, means it is added after this last element, means it is added behind this element, means it is added from a rear side. Okay. The rear pointer is then moved one position forward and it is shifted one side forward, which I already told you. This NQ operation basically follows the principle of the first in, first out. Okay, as I already told you that what is a first in first out, so I don't need to tell you. And coming on the next slide, next operation, that is DQ. Now let's talking about the DQ. DQ is opposite of a NQ, means we are deleting the Q from the front side, means we are removing the first element from the Q. It is opposite of the NQ, means in NQ we are adding element from the last side. In DQ we are removing element from a front. Okay, it is also called a pop or delete function. Means here it is written that you can see that when DQ operation is performed on a queue, the first element of the queue is removed. Means when DQ is performing, this first element is going to removed and this element is coming to the first position. This is what a DQ. The removed element is returned as the output of a DQ operation. And we can say that when queue is empty, when it means that no one is standing in the queue, then we cannot perform a DQ. Okay, which means that no one is standing in the queue, and we are not going to remove anyone because there are no one. So we cannot perform a we cannot perform a DQ in empty queue. Okay, and in NQ we can perform that, means we can add a more person, but in DQ we cannot. Okay, and this condition is called a underflow condition. Okay, this is our DQ. I hope so that you are clear with what difference between DQ and NQ. So coming on the next, some more operations in queue. The front means this operation returns the element at the front end without removing and it. And rear operation, this operation returns the element at the rear end without removing. Is empty when this operation indicates that whether queue is empty or not. And is full operation, this operation indicates that whether queue is full or not. In the size, this operation obviously tells about the size of the queue, or we can say the total number of element it contains. So these are the some basic operation in queue. We can perform that NQ, DQ, and these are some more operations we can perform in queue. So let's start with the type of queue. There are total five type of queues. In the further video, we are going to discuss about all the five types. So let's start with the first one, that is a circular queue. Circular queues basically when last element is connected with the first element to make a circle, means they are in a proper loop. Last element is connected with the first element, and this queue, circular queue follows the principle of FIFO, first in, first out. And that circle we call that circle that made from a first element to the last element. That circle is called a ring buffer. For example of a for example of circular queue, that is a traffic system. In a computer controlled traffic zone, circular queues are used to switch on the traffic lights one by one repeatedly as per the time set. Okay, so now let's talk about the second one, that is input restricted queue. In this type of queue, input can be taken from only one side, that is rear, and deletion of the element can be done from the both side. Okay, like you can see in this figure that um, insertion of the element is taking place from only the rear side, but the deletion can be taken and is taking place from the both the sides, rear and the front also. So this type of queue is called an input restricted queue. Here it is written that in this type of queue, the input can be taken from one side only, that is rear, that I already told you. And the deletion of element can be done from the both side. That you can see that here, deletion can be taking place from the both sides. This kind of queue does not follow FIFO because deletion is taking from both the side. That's why it is not following the FIFO property. And this queue is used in the case where the consumption of data needs to be in FIFO order, but if there is a need to remove the recently inserted data from for a reason, and one such cases can be irrelevant data performance issue, like you have some irrelevant thing in the last or and you want to remove that, you can remove from the rear side also and from a front side also. It doesn't matter. Okay, now let's talk about the third one, that is output restricted queue. This is basically like I will give you an example, like you are standing in a queue of some mandir or somewhere else, and some VIP comes in and they take your place and stand in front of you. This is what a output restricted queue. That queue and queue is taking from a rear side also and front side also. Means element can be inserted from the front side also and rear side also. And DQ is only happening from a front side. Okay, like here it is written that in this type of queue, the input can be taken from the both sides. Like I told you, input is taken from the both the sides. Okay, and deletion of the element can be done from only one side. I can see that the deletion of element is taking from only one side. This key queue is used in the case where the inputs have some priority order to be executed. Like I already told you, someone take place in your place in Mandir or somewhere else. You are standing. That's what is happening here. The priority order or priority data can be executed mm, first, and input can be placed even in the first place, so that it is executed first. Now talking about the third one, double-ended queue means in this type of queue, NQ and DQ can happen from the both the sides. Means you can add and delete from rear side also and from first side also. Okay. Um, like here it is written that queue data structure in which insertion and deletion operation are performed from the both ends. Like it is shown in the figure that it is happening from the both side. Okay, that means we can insert from both front and rear position and can delete from both fronts and rear. Since DQ supports both stack and queue operation, it can be used in both. Okay, like you are you can see that it is happening from the both the side. It is simply means that NQ and DQ can happen from the both the sides. So talking about the priority queue, what is a priority queue? Priority queue is a basically if I set an element on a priority queue, then it will be executed first. There are two types of priority queue. The first one is ascending priority queue. In this, the element is inserted as it is, but while deletion, the smallest one will be first who is going to out or can be deleted. Like let's take an example of an array. Like we are going to insert element 4 to it in a same order. It will be inserted in the same order, but while deletion, the smallest one means the 2 will be get firstly deleted, and then 4, then 8. It will go in ascending order. And talking about the second type of priority queue, that is descending priority queue. In this also same, the element is inserted as it is, but while dequeuing it means while deletion, the biggest one means the biggest element will be deleted first. Like the array having an element of 4 to 8, and while deleting the order will be 8 4 2, because in descending priority queue the largest or biggest element will be deleted first. So this is all about the queue. I told you about all the basics or types of queue and what the operation happens in the queue. Now we are going to move on to our next part, that is our example we are going to take for our further coding on a queue. Like I will take up real life based example. Let's move on there. Priority queue on our next part, where we are going to take our practical life example where queue is happening, property of queues are happening or implementing. Let's take an example of a bank. Let's simulate the bank scenario where customers arrive and stand in a queue to perform a transactions like deposit and withdrawal, and we are going to implement these transactions or properties of queue in the bank scenario, where we are going to do code on that part. How customers comes in the bank, stand in a queue, perform their transaction withdrawal type, sorry, transaction type with amount and or something else they are going to do. So we are going to do with the help of coding. So let's start with our coding part of a bank simulation, in which we include a transaction type, withdrawal and deposit, and other more things which are related to the queue in our bank simulation. So let's start with it. So let's first we have to import our DQ. Okay, collections, import import DQ. Okay. Mm, Now let's make a constructor called a class, in which construction called bank. Okay, in which we include let's define our define self 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 dot q first. Okay, self dot q equal to dq. hmm, dq. Okay, Hmm. Non-define our process of transaction. Sorry. NQ customer def NQ NQ underscore customer self. We are making self dot customer. For this, you have to some basic knowledge of Python, so you can understand whatever I'm doing right now. Okay, self dot queue in which we are going to append customers who are coming. Okay, customer. Now we are going to give a print statement like f and customer square brackets name coming out of curly and square bracket join the queue means the new customers are coming who are going to join the queue. Hmm. Why it is showing error? Wait a second. Oh, sorry, curly bracket should be ended here. Right now it is okay. Yeah, now it is okay. Now let's define our enemy process. Def process transaction. Okay, section transaction transactions itself. Now we are defining our transactions. Okay, we make a while loop with self dot queue. Okay, now equal to customer equal to self queue means new customer are coming to going to add in queue. Self dot queue. That pop left means they are going to add or leave transaction transaction type means which type of transaction they are doing or they depositing or withdrawing the money. Here it means this. Okay, customer square brackets transaction type. Okay, transaction type transaction type now amount how much amount they are depositing or withdrawing it equal to customer mm, square bracket and customer sorry amount the customers are depositing or withdrawing. Okay, now coming to the next part. If transaction type we are defining what if transaction type is deposit or withdrawing what they are it is going to show us. Okay, what if transaction type equal to deposit. Okay, and processing, sorry, and processing, processing deposit of dollar. We are taking a pound in dollars, so we are putting right here dollar sign amount. How much amount they are going to deposit or withdraw? Sorry, deposit for customer, customer name. Okay. Mm. So this is for a deposit. If the current transaction type is deposit, then mm, processing of deposit amount will be going to print. Okay. I- If LF other transaction type is withdrawal. Okay. What if transaction type is withdrawal? Then we are going to print that processing withdrawal, processing withdrawal of dollar because we are taking amount in dollar. That is amount, how much amount they are going to withdraw for customer, customer name, customer, okay, then name, wait, name, okay, okay. If other than these of, if other transaction then deposit or withdrawal, then we are going to enter invalid statement. Means if mm, transaction is not of type deposit or withdrawal, then it will going to print invalid. Mm. Invalid transaction type, transaction valid transaction type for customer, means customer, the name of customer, uh, name of a customer. Okay. For now this is completed. Other than if there is a same type of transaction that we have given the command, then it will print then it will print mm, customer 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 name, customer name, transaction is completed. Okay. uh, Transaction is completed. So we are done with this constructor. Now coming another type. Okay. bank equal to bank. Okay. Mm. That's get customer input. Now we are going to input. Taking a customer input means we are going to give input name equal to mm, input. Enter customer name. Enter customer name. So first input is this. Then transaction type. What will be transaction type? Oh, wait a second. I have done some mistake. TR transaction type. Okay. No, no, there is a no mistake. And it's showing that error. Input. We will take an input from user. Then enter a transaction. Transaction type means what type of transaction it is doing deposit or withdrawal. Okay, withdrawal. Now next one, that is amount. How much amount they are depositing or withdrawing from a bank. We will take a float because it is integer type. We are using a float here. Okay, enter, enter transaction amount means okay. Oh, sorry. Hmm. Done. Name. Return name, transaction, transaction type. Okay. Now amount. It will remove amount. UNT. Okay. Now, uh, now let's do num is equal to customer. Customer equal to input. And the number of customers means we are asking for the how many customers are coming to the queue. It will given by the user. Okay. customer. Okay, name का customer. Yeah, sorry. Uh, Means num equal to, sorry, num parenthesis bracket customer, customers. Hmm, hmm, get customer, get customer input. Okay, bank dot nq. We are calling our function here. Ban nq customer, customers and customer. Ban dot process the transactions. Means after enqueuing it, mean adding the customers in line, that it will print a bank process all the transactions. Okay, bank process the transaction. Now here we are completed with our code. Okay, now let's check our code by running it. Let's run it first. We are going to save it. It got saved. Let's run it. Okay. Mm, Let's number of customers. Let's take there are four customers in a queue. Means there are four customers are coming into the queue. It is asking for a first customer name. Let's give my name in first customer Saurav. Okay, transaction type will be our deposit or withdrawal. Let's take a deposit. Okay, amount let's take a 500. Okay, Saurav joined the queue. See, it showed that I joined the queue here. ठीक है now I am in the queue. Now let's add a second customer. I'm calling a name of Kundan. Okay, we like let's take he is withdrawing the money. Withdrawing the money. Amount will be like 400. Okay, let's see. It's enqueued means he joined the queue from the rear side. Okay, now add a third customer that is Kushagra. Okay, transaction type will be deposit and the transaction amount let's take 100. Kushagra joined the queue. Now it's means ongoing is joined behind the Kundan means Kundan is one step forward to the Kushagra right now. And okay, this is what we have called NQ here. Now add our last name that is mm, Uttam. Okay, transaction type will be withdrawal. Withdrawal amount will be 600. Okay, Uttam transaction is completed. Okay, see in here it is shown that Uttam joined the queue. Now what we say what is a NQ? NQ is the first one who is going to enter in the sorry, entering the queue from the last. Okay, this is what we call a NQ. Now what is a basically queue is about a first in first out. Here you can see that I am the first one who joined the queue. See, I am the first customer Saurav. Okay, here shown that Saurav joined the queue. Now you can see that here Saurav transaction is complete. I am the first one whose transaction is completed means it defines the property that first in first out property. And you can see that Uttam is joined in the last in the queue and he completed his transaction in the last. So this code defines that property of a queue that first in first out. So this is for us right till now. We have completed the code, completed a practical example in which we are explaining what is first in first out property of the queue, and we done the code by taking a practical live example on a bank simulation. So this is enough for this video. Now we will meet in another video. Thank you for watching.